Are you interested to learn how this filling machine with different bottle sizes works? Let's see it together. Hi friends, welcome back to the channel. You asked me in the comments to have a video about this topic. So today we are going to talk about the shift and rotate operations and how to use them in TIA Portal. In the end, we will create together a project to track bottle positions and fill them with the different sizes using a shift register. First, I'm going to explain what shift and rotate mean. As we know, the binary format of 5 is 101. If we want to store this value in a byte in PLC memory, it would be like this. Now, if we want to shift all bits one bit to the right or left, what do we have to do? For example, if we move all the bits one to the left, we will have this value. Each time with shifting, 0 will be added to the first bit from the right. The new value now is 10 in decimal. Or if we shift the bits to the right, the last 0 comes from the outside and 1 that was in the bit 0 is shifted now by 1 to the left. In fact, it will be deleted and the new value is now 2. So we can shift the bits to the right or left and change their position. But as you see, when a bit comes to the end of the right or left side, with another pause it will be shifted outside and actually it will be deleted. Sometimes we need these bits again and we don't want them to be deleted. In this case, we can use rotate. Rotate is exactly like shift, but the bits which go to the right or left are not deleted and they come back to their extreme left or right. Same thing we can do with TIA Portal. Go to the program and open the main OP. From the instruction, there we have shift and rotate. SHR shift to the right, SHL shift to the left, and rotate to the right, rotate to the left. Let's put the shift and rotate right into the program. Shift right is used to shift the content of the input in bit by bit to the right. Input n determines the number of bit positions by which the value is to be shifted. For example, with n equal to 4 bits will be shifted when the input enable is activated. Let's define each input and output. If you open the 3 question mark, we can select the data type. If you don't select the data type, TIA can detect automatically the data type according to the type of the variable in input in. En is enable. Be careful, if you leave here open, this function will be executed with each PLC cycle time, which is approximately 5 milliseconds. So use always a button here. But we cannot turn it on and off very fast in 5 milliseconds. It takes 1 or 2 seconds to do this, and during this time the shift or rotate register will be activated hundreds of times. So we define in the software for this button a rising or falling edge. In this case, with each activation of the button, a function will be activated just once. The inputs and outputs for rotate are the same as shift. I'm going to simulate the program. Let's modify the input value of 5 in binary format. When there is no pause in enable input, the data is 101, which is 5 in hexadecimal. When we have a pulse in enable, bits are shifted to the right. With another pulse, bits will be again shifted. Let me first modify the new output in the input. That's how bits are shifted with every single pulse. One interesting thing, if you remember in data types, when we have a signed value, for example, a signed integer, the first bit is the signed bit, and if we shift and change this bit, the sign of the value will be changed. Let's modify a value with a signed bit 1. As you see, the decimal value is minus. I'm going to shift the bits. Now our shifted value is positive because the signed bit is 0. TIA has a solution for that. When you choose the data type as a signed integer, the most significant bit will not be changed. Here we have 1 in the highest bit, and the shift operator with each pulse will not change it. It actually copies this value to the next bit. That's the difference between shift and rotation. For rotate, you can only use word, double word, byte, and long word. Also be careful using the data type. If your variable is a word and you select for rotate or shift byte, only 8 bits of the word, which are 16-bit, will be shifted. Alright, that was the basics of rotate and shift. Let's do a project together with the shift operation. The most application of shift in the real world and industrial project is a shift register, where you have, for example, a machine with some levels or steps that each one is considered as a bit. So we shift basically these levels from each step to another one. For example, here we have a bottle filler with 8 filling nozzles filling the bottle with 2 different sizes, 250 milliliter. Each filling station is considered as a level or a step. So we need to track the bottles to know their size and position and fill them according to the size. How we can do this project in TIA Portal? Imagine these 8 filling places as data bits of a shift register. When the size of the bottle is 500 milliliter, we consider the data bit as 1 and 200 milliliter as 0. Now we can use a height sensor to detect which bottle is 200 milliliter and which one is 500. I have used another sensor. Think about it and write in comments the reason for using this sensor. First, we have a big bottle. The height sensor detects it and gives 1 as the output. With starting the conveyor, bit 1 will be shifted. Next, we have a 200 milliliter bottle, which gives 0 from the height sensor. Similarly, the data bits in the form of 1 and 0 are being entered into the data register and shifted right with each new bottle. In the end, based on this information, we can create the shift register and we know which bit is 0 or 1. In this way, we can track the bottles and fill each one correctly. Let's see our program in TIA Portal. To save time, I have already created the program. I just show you and explain each network. First, we need to detect big and small bottles. So when the height sensor is false and the second sensor is true, it means we have a small bottle. And when both are true, we have a big bottle. With each bottle, the program gives you 2 seconds, and after that, the conveyor starts for 4 seconds to move the bottle to the next station. I used a counter to count up the bottles. We have 8 stations and our register is 8 bits. So with the 8th bottle, the counter will be reset. After that and after 6 seconds, the filling will be started. 6 seconds is 2 seconds for waiting and 4 seconds for the transition of the last bottle to the filling station. Next network. As you know, when we shift the bits to the right, 0 will be added from the left. But when we have a big bottle, we need to add 1 to the first bit from the left. So with this network, we can do this. 80 in hexadecimal is equal to this number in binary. Next, we need to reset the shift register when the filling of 8 bottles is done. So when the filling is finished and with falling edge, 0 will be moved to our register. And also stop the shift operation when the number of bottles is 8. Here we have the main network with each pulse of bottle detection, and if the number of bottles is not 8, the bits will be shifted to the right. And finally, filling network. When a bit of the shift register is 1, a long filling with 4 seconds will happen. If the bit is 0, filling will be just 2 seconds. Let's start a simulation. The first bottle is big. After 2 seconds, the conveyor will be started. The shift register is now 40. Let me show you 40 in binary format. As you see, 1 is shifted to the right. Next is small. And then again big bottle. And the last one is again small. In the end, we will have this shift register. I've increased the filling time to understand the process better. The big bottles with the value 1 will be filled 40 seconds and the small ones just 20 seconds. You see the bits are exactly like what we have here and the bottles are filled correctly. Shift register and counter are again 0. Alright, this was a simple example of using a shift operator in the TIA portal. Based on your requirement, you can change some parts and use it for yourself. This program has also some weaknesses that I want you to tell me about in the comments. For example, one of them is the filling sections. What happens if all the bottles are small? For more exercise, write a program with a shift register to detect the boxes. And at the end of the conveyor, an arm sorter will sort the boxes to the right and left. I hope this video could help you improve your TIA Portal programming. See you next video. Bye.